Next, I want to walk you through a whole example of an F equals MA problem, step by step, to show you the full procedure all at once of how I would solve it. So here's a simple example problem. We have a boat. The boat is under the influence of two forces. The wind is pushing it in one direction and the water is pushing it in a different direction. So what will be the acceleration of this boat due to the combined effect of the wind and the water acting on it? Okay, so step one, I need a diagram. This is way too many words and numbers for me. I cannot understand what's going on at all yet. I have you do not have to, by the way, this is another really key tip in this course. You absolutely do not have to be able to read this question and just know what the answer is. Absolutely not, absolutely not. You can't really wrap your head around this question at all until you start going through the procedure and breaking it down. So you say to yourself, okay, this is an F equals MA problem. What is step one of an F equals MA problem? Step one is draw the free body diagram. So put everything else out of your mind and just focus on drawing a good free body diagram. So here's my boat. Okay, let me reread the question now, thinking just about free body diagrams. Okay, the wind is pushing it east. Okay, the wind is pushing it east with a constant force 500 newtons. So that's a 500 Newton force east. And then the water pushes it southeast with 150 newtons. So this is going to be going southeast. This vector should actually be much shorter than the 500, but I'm not going to worry about that because I don't want this to be legible. So this is a 45-degree angle. And this vector is going to be 150 Newton. By the way, I don't think I mentioned it in the previous videos, but capital N, this is called a Newton. This is the SI unit of force, and it is equal to kilogram times meter divided by second squared. So it's made up of all SI units. Okay, anyways, back to the diagram. All right, so there were only two forces acting on the object, so I think my diagram is done. I got both the forces in there. So step one, draw the free body diagram. Check. Step two of the procedure was break the forces into their components. Again, this by itself is very manageable. We solved a whole bunch of problems like this. Okay, let's do the X direction over here. We'll do the Y direction over here. So the 500 Newton force is in the positive X direction. That one doesn't need to be broken into its components because it's already in the X direction. The 150 Newton force, that's in the positive X direction, but it's in the negative Y direction. And then I'm going to have 150 is the magnitude. And then I have a 45-degree angle. With a 45-degree angle, it doesn't actually matter about cosine and sine, but let me do it based on the picture I drew. If I draw that right triangle, I would end up getting cosine 45 here and sine 45 here. Okay, so done. All my forces are broken into their components. The next thing I do, actually, let me crunch the numbers really quickly first. Cosine of 45 times 150 is 106. So this will be positive 106. And this one here will be, if I can get my own face out of the way here, this one is 106 newtons in the negative direction. Let me get it. Kind of ran out of space here. We need to get a negative sign in there. Okay. So step two, break all the forces into components. Check. Step three, sum all the X components and then sum all the Y components. So the sum of all the X components is going to be 500 plus 106 is positive 606. In the y direction, there's only 1, so there's nothing to sum. It's just going to be negative 106. Try to do that a little neater. Okay, so those are the sum of my x components and the sum of my y components. So step 3, check. Step 4 of the procedure was set this equal to MA. So over here, this one is going to be equal to MAX. M was 2,500. So this will be 2,500 kg times the x component of acceleration. And over here, this will be 2,500 kg times the y component of acceleration. So then that means, let me just go up here. That means that AX equals, that's supposed to be an X. AX equals 606 divide 2,500 is positive 0.24. And acceleration is meters per square second. And in the y direction, I'll have AY equals 106 divided by 2,500. So this is going to be minus 0.042 meters per square second. And there's the acceleration. Those are the two components of the object's acceleration. And then finally, if you wanted to know the magnitude of the acceleration, as usual, you could do square root of AX squared plus AY squared, if that's what the question was asking for. And then if you wanted to know the direction of the acceleration, you would need to draw this. We have something like this. It's pointing down and right at some angle. And you could solve for that angle with tangent of theta equals AY over AX. And if you want to know the direction of the vector. So that's the basic process of how you break down one of these problems step by step and turn it into something that is simple and solvable.